Another exciting math lesson. Today we're going to talk about proving trigonometric identities, specifically the Pythagorean identity. Alright, so during this lesson you're going to learn how to use the Pythagorean identity to solve for missing sides in a right triangle on a coordinate plane. Okay, vocabulary, you know all these. The ratio, sine is the ratio of sides of a right triangle such that the sine of an acute angle is equal to the opposite side divided by the hypotenuse. The cosine is the ratio of sides of a right triangle such that the cosine of an acute angle is equal to the adjacent side divided by the hypotenuse. Tangent is the ratio of sides of a right triangle such that the tangent of an acute angle is equal to the opposite side divided by an adjacent side. A circle is a round figure which the distance from the center to any point on the figure is the same. The equation is x minus h squared plus y minus k squared equals r squared, where the center is hk and the radius is r. We're going to be talking a lot about circles in the next unit. Okay. The unit circle. The unit circle is a circle on the coordinate plane whose center is at the origin. Remember, the origin's at 0, 0. And has a radius of 1. So our circle equation, x squared plus y squared equals 1 squared x squared y squared. Okay. We solve for y equals plus or minus the square root of 1 minus x squared. My center is 0, 0. R is equal to 1. We're going to use kind of this stuff to prove the Pythagorean identity. So I want you to keep this image in your mind. The equation describes all points on the unit circle around the origin. So all of these are going to be a radius of 1, right? 1 unit away from the origin. Okay, so Pythagorean identity proof. Okay, so the first thing I'm going to do, I'm going to draw my radius, which we know is 1. Next, I'm going to draw just an arbitrary triangle here. Okay. So we know this is x units away and y. This can be for any right triangle that we draw. Okay. Well, if we're doing like our sine and cosine, sine would be y over 1. So what we prove here is we can say, well, y is equal to the sine. We'll call that angle theta, sine theta. Same thing for x. X is the adjacent side over hypotenuse. So we know x equals the cosine of theta. Okay, now we can substitute. So if I'm looking to prove that this is a 1, right, we can say x squared plus y squared equals 1. Then we can substitute in these terms. We can say cosine squared theta plus sine squared theta equals 1, which these two are the same. Doesn't matter if you put sine or cosine first. But we can show the sine and cosine. If I square them and add them together, they're going to equal 1, which is just the Pythagorean theorem. Make sure that you put the squared before, like in between the cosine and the angle measurement, in this case theta. This allows us to say that we're squaring the whole function and not just the angle. Okay, so now we can use this to be able to solve some things. The Pythagorean identity is pretty useful in finding the sine of an angle if given the cosine and vice versa. Okay, so if I only know the sine, so like the ratio, I can find the cosine as well. Okay. So it says, using the Pythagorean identity, given that the sine of theta equals 4/5, find the cosine of theta. Okay, so I know sine squared theta plus cosine squared theta equals 1. Okay, well I know sine of theta is 4/5, so I'm going to say 4/5 squared plus cosine squared theta equals 1. I'm going to square this, I get 16/25. Getting a little excited here, going too fast. Cosine squared theta equals 1. I'm going to subtract 16/25 from both sides. I'm going to say cosine squared theta equals, instead of writing 1, I'm going to write that as 25 over 25. So 25 over 25 minus 16 25ths gives me 9 25ths, right? And then I have to take the square root of both sides. And I have the cosine of theta now equals plus or minus the square root of 9 is 3, the square root of 25 is 5. And here's the tricky part, is we know cosine, so let's draw this unit circle right here. Because I need to know, imagine that's a perfect circle, unit circle, center at 0, 0, is my x value, right? That's what we decided a couple slides ago. Well, so cosine is adjacent over the hypotenuse. So here's the trick, is I don't know if I have 3 over 5 or negative 3 over 5. It could be in quadrant 1 or quadrant 2. I don't know if this is positive or negative. So if it doesn't tell you, your answer would be this, but it might tell you find cosine of theta in quadrant 1 or so forth. You'd have to be careful of whether this is going to be positive or negative. It all is based, oh sorry, you guys are probably thinking cosine does not include the opposite angle. It would be that angle measurement right there, okay? And sine is 4/5, so I know that my sine is positive, so it has to be in that upper quadrant, okay? So I don't know if it's 1 or 2. If this said sine is negative 4/5, it could be the lower half. Okay, now you try. Given sine theta is equal to 3/5, find cosine theta if it is in quadrant 1. Okay, so I know it's going to be, over here, and we can probably already guess this is going to be 4, because it's a 3, 4, 5 triangle. But let's practice this skill that we've done. So I'm going to say 3/5 squared plus cosine squared theta equals 1. We get 9 25ths plus cosine squared theta equals 1. We're going to subtract 9 25ths from both sides. We get cosine squared theta. Remember, I can rewrite this as 25 over 25. 25 minus 9 gives me 16 25ths. We take the square root of both sides, and we get cosine theta equals plus or minus 4/5. I know it needs to be on the positive side. It is for that adjacent side. And bam, there we go. Using decimals, given sine theta equals 0.22, find cosine theta if it is in the first quadrant. This needs to equal to 1. Okay. So we would say, oh no, so yeah, it still equals 1. So we'd say 0.22 squared plus cosine squared theta equals 1. I would subtract that, so I'd have cosine squared theta equals 1 minus 0.22 squared. So what I'm going to do real quick is I'm going to take that 0.22, I'm going to put that in my calculator. So I'm going to say 1 minus 0.22 squared, get 9.516, and then we have to take the square root of that, of my 0.9516, and get 0.9755. So we get 0.9755. So I took the square root. I did 2 calculator steps there. I know that's what my cosine of theta needs to be, and we are set. If you have any questions about how we did that, please come and talk to me. I'd be happy to help you out. Have a great day. We'll see you next time. Thanks.